Hello and welcome to day 13 of Jamb Mathematics in 30 days. To those of you who have been following the series so far, thank you so very much, and I hope that you are really having a wonderful time as we go in this series and go on to ace Jamb Mathematics. Now, to those of you seeing this video for the first time, this is Jamb Mathematics in 30 days. This is brought to you by the Learn Network, where we believe that when you dedicate within 30 to 45 minutes of your time daily, you should be able to prepare accurately or prepare well enough for Jamb Mathematics. So those of you who are thinking Jamb Mathematics is very difficult, that will be a thing of the past if you just follow this series from start to finish. Now, this is day 13, so please do well to check out the videos from day 1 up until today. And then we believe at the end of it all, you should be able to ace Jamb Maths. So in day 13, we are looking at the topic called loci. Now, loci is a plural word for the word locus. And in geometry, locus refers to a set of points that satisfy a given condition. So when you're given a condition based on line, whether they are perpendicular, whether they are parallel, or whether you are relating it to a circle, then the 2 points or more that satisfy that condition given in your statement is what we refer to as the loci. Now, what Jamb expects you to be able to do to be able to pass loci in Jamb Math, it's very simple. They expect that you should be able to identify and interpret loci relating to the following. So you should be able to relate it with parallel lines, perpendicular bisectors, angle bisectors, and to circle. Just these 4 things, and then you are on your way to acing loci as far as Jamb Mathematics is concerned. Now, if you want more explanation on this, you can check out many other materials that will help you understand loci in full. However, for now, let's just go on to solve Jamb past question on the topic of loci. Let's do it. This question says, find the locus of points equidistant from 2 straight lines y minus 5 equals 0 and y minus 3 equals 0. Now, considering these equations that we are given, we see that we have lines that do not intersect with the x-axis at all. So we're going to be having horizontal lines that are parallel. Since they are parallel, this is what we do. So we only have the y coordinates. So from the first one, when y minus 5 equals 0, this implies that y equals 5. And then from y minus 3 equals 0, this implies that y equals plus 3. So working with these two, we can then find the midpoint of these 2 lines. So the midpoint will therefore be 5 plus 3 divided by 2. So we would have 8 divided by 2. So we can then say y equals 4. Now bringing 4 to the other side, we'll have y minus 4 equals 0. So this is the line that is equidistant from these 2 points. So the correct answer here is B. This question from Jamb 2024 says, P marked by the coordinate x, 4 and Q, which has the coordinate 10, 8, are 2 points joined by a straight line in a plane. Now, if the midpoint of the line is 9, 6, find the value of x. Now, to solve this, let's note that this coordinate here, we have the x coordinate, the y coordinate, the x coordinate, the y coordinate, and as well in the midpoint here we have x and y. So what we have missing is this value of x in the x coordinate. So to find the midpoint, the coordinate of x for the midpoint, we're supposed to have this x added to this 10, and then we divide this by 2 in order to get the x coordinate here, which is 9. And if you test for y, you see that it is correct also, because 4 plus 8 would give you 12, and 12 divided by 2 will give you the 6 that we have here. So when we check here, we can then cross multiply, taking 2 here. So we have x plus 10 to give us 2 times 9, which is 18. So x therefore becomes 18 minus 10. So x is 8. So the correct option here is C. This question says the locus of a point equidistant from 2 points P, which is given by the coordinates 6, 2, and R given by the coordinates 4, 2, is a perpendicular bisector of PR passing through. So that is, we have to find the coordinates of the perpendicular bisector, right, that divides point P and R into two equal lines. So to put this in perspective, let's consider this line and call this P and this R. And the coordinate of P is 6, 2, and the coordinate of R is 4, 2. Now, the perpendicular bisector would be a line that comes to the midpoint here, dividing this into two equal lengths. So, to find the coordinates of this point is what we are asked to do. So, how do we find the coordinates of this point? Now, recall this divides into 2. So, to get that, we have to find the average of each point. So, to get that, we'll say x1 plus x2 divided by 2, comma, y1 plus y2 divided by 2. Now, this would give us x1. This is x1, so we have 6 plus x2, 4 divided by 2, comma, y1, 2 plus y2, 2 over 2. So what we have here is 10 over 2, comma, 4 over 2, which gives us the x will then be 5 and y is 2. So we have 5, 2. So the correct option here is B. In order to solve a question like this, where we have to find the locus of a point that is equidistant from 2 points P and Q with the said coordinates 1, 3 and 3, 5. Here's an equation that helps. Now we'll have y minus y1 equals x minus x1 multiplied by the perpendicular bisector. And to get the perpendicular bisector, this is -1 over slope. So meaning we start first by getting the slope. And when we do get the slope, we can then go on to find the equation. Now, working with this, our slope m will therefore be y2 minus y1 over x2 minus x1. Now, having this now, we then go on to our coordinates. Remember, this is x, this is y, this is x, this is y. So this will be x1, x2, y1, y2. So y2 is 5 minus 3 over 3 minus 1, which gives us 2 over 2, which is 1. So our perpendicular bisector is therefore -1 over 1. So what we have here is -1. So to then go on to solve this, we're going to apply this equation now. So where we have y minus y1 into, now the perpendicular bisector is -1. So we're going to be having from here, x minus x1. Now, we don't have these points yet, so let's go on to find the point x1 and y1. To do that, we're going to find the midpoint. And our midpoint is x1 plus x2 over 2, comma, y1 plus y2 over 2. So let's do that. x1, that's 1, plus 3 over 2, comma, 3 plus 5 over 2, close bracket. Now this is 4 over 2, comma, 8 over 2. So what we have here is 2, comma, 4. Now let's put it into this equation. So y minus y1, that's 4, equals minus 1, open bracket, x minus x1, that's 2, close bracket. So from here we see y minus 4 equals minus x plus 2. So we write this and say y equals minus x plus 2. Now when minus 4 comes to this other side, we have it as plus 4. So y equals minus x plus 6. Now we compare this with what we have in the options, and we see that it is the same as option A. So our answer is A. This question asks that the locus of a point which moves so that it is equidistant from two intersecting straight line is the, and then we have 4 options here to pick from. So we have perpendicular bisectors. Now perpendicular bisectors do not move. Once you move a perpendicular bisector, the 2 points will no longer be equidistant, right? In the case of angle bisector, like when you consider when you're having a construction of an angle, for example, you're going to have 2 lines that will bisect each other to form an angle like this. So by the time you try to bisect this, what you create is a line that is equidistant from these 2 lines. So we see that every point on this line is equidistant from these 2 intersecting lines. So we see that the answer here is B. So the correct answer is angle bisector of the 2 lines. This question asks that we find the coordinates of the midpoint of the line joining the points -3 and 5 and then 2, 10. So to find that coordinate, we're going to apply this equation. Now before we do that, if you are yet to subscribe to the channel, please do so, as it helps us to be able to make more videos like this that are helpful. And please do well to also share it amongst your friends and circles so they too can have access to these educational videos that is changing lives. So to solve this, all we need to do is to find the midpoint. And to get midpoint, we've discussed this earlier, that x1 plus x2 divided by 2 will give you the x coordinate for the midpoint. And then y1 plus y2 divided by 2 will give us the y coordinate for the midpoint. So let's apply that. Starting with x. So we have -3 plus 2 over 2, comma, y, we have 5 plus 10 over 2. Now what we have here is -1 over 2, comma, 15 over 2. And when we compare this with the options provided, we see that it is in line with option D. So the answer is D. This question says, what is the value of k if the midpoint of the line joining -1 minus k, comma, -4 and 2, comma, k plus 1 is -k, comma, k. Now, to find this, we can choose to either work with the x coordinate or the y coordinate. But whichever one you choose, you should get the same answer. And to prove this, I will do both side by side. So on this side, we'll do for x coordinates. On this side, we'll do for y coordinates. So working with the x coordinate, let's find the midpoint of our x coordinate. That is, we'll be having 1 minus k plus 2 all divided by 2. And this should give us minus k. So from here we see that we have 1 plus 2. That will give us 3 minus k equals 2 coming here will be minus 2k. So what we have to do is to bring negative 2k to this point and bring 3 to this point. So we have minus k, and this will become plus 2k equals, now 3 coming to the other side will become minus 3. And when we do this, it's just like saying 2k minus k, and that will give us k equals minus 3. So k is minus 3, which is option A. But let's test with the y coordinate so that you can see that you can do it whichever way you want. So for the y, we're going to be having minus 4 plus k plus 1 all over 2 equals k. Now from here we see that when we cross multiply, we would have minus 4 plus 1, which will give us minus 3 plus k equals 2k. Collecting like terms, we would have 2k, then plus k come here becomes minus k equals minus 3. And the difference here is k, so k equals minus 3. So the same answer both ways, all saying the answer is option A. Now you can check out many more questions on the topic loci to practice even more. And also do not forget to like, share, and subscribe to this channel. You can also click the notification bell so that it will alert you every time we put out a new content for you. See you in the next video.